Okay. Now it's recording? Oh. Okay, so we did Marie's lesson. The first page, we didn't really change anything. We said this would be, it started out with a review from last class, so we kept it as a review from last class. But the answers we used, we did change this page a little bit because when Marie taught it, she didn't use a lot of guiding questions to probe their thinking. So we said we'd use more guiding questions. And also, she didn't have a lot of wait time when she answered. She kind of sped through it a little bit. We would also, before on this page, we would do the examples on the board before we showed them this. And have more of a discussion about the investigation section, and then use a weigh scale to represent the effects of adding an integer was another thing we got from feedback. Okay, you gonna go next?
Okay, for this one, the suggestion we thought is to start off, oh, I can't even see it. We'd circle the -2 and the 4 to begin with, because the point of this is to show what happens when you add a number to both sides, and then we'd go through and add the numbers to both sides. So we'd end up with 0 is less than 6, and then circle these after, because then they can see the relationship that the inequality still holds. You just move over 2 sections on the number line. I think that's all that we really changed here. Yeah. This one we just kept the same. It's just kind of examples. Oh, yeah, it's examples. I think, again, in my language, in my teaching, I asked what's the next step. Ask what could we do next and why. So rewording my questioning so that it's not one right answer necessarily. We could. And then separate colors for each of the separate questions. So this one could be in red, green, and blue, just so we can see. And because then when we put it up on the number line, if we had this one in red, you can find it on the number line. Oh, I can't read that. And then if the next one's in green, you can easier to compare, I guess.
The next one was her essential question. So it started out, what happens when the same number is added to or subtracted to both sides of an inequality? What do you think will happen when we do the same thing to both sides? And we changed it to what happened when the same number was added or subtracted to both sides of an inequality, because in the last question that's what we did. So we are going back to what they just learned. So that's what we'd ask them, and then can they make a general rule? So have them have a discussion about what they could create as an idea, and then what do you think we have to do to the same thing to both sides? So it's pretty much the same. Okay.
So for this one, we before I had it separated, like this was all showing. I didn't have this blind here, and we just, oh god. We went through both of the questions without any like inferring from the students. Okay. So maybe we'd start and we go through, because they already know how to solve equations. So basically, how would we solve this linear equation? We go through, find an answer, and be maybe, well, what happens if we change the sign to an inequality sign? So we'd go through the same thing. Exact same question, it's just an inequality. And then I used to have 2 number lines on the bottom, so I'd have the one represented on this side and the one represented on the other side. But if you have it on the same number line, you can kind of see the relationship between the two a lot easier. That's all we did there.
Okay, number 7. Marie had a question where it had a decimal here, and we decided to change it just to whole numbers because it's something they've already done, so they're kind of building on what they already know rather than throw something new at them that you haven't really taught them before. And the next one, we didn't change anything about it. We left it the same. So they're still solving for a variable and an inequality and still graphing it on the linear line.
So for this one, I screwed up in my language. I asked, when a solution of an equation is verified, we can say that the solution is correct. When a solution of an inequality is verified, we can only say that's just the solution is correct. Why? And I I said something about most likely to be true, which doesn't really make any sense. Basically, just the linear inequality is satisfied by using this. So our answer would be we cannot say the solution is correct unless we have checked every number, which we know is impossible because they can't go through and check every number, which is less than. So we only say it's correct for the numbers we do check, which suggests it's correct for any other numbers in that range. So just an estimate more, again in my language.
Okay, so this is a word problem that she did. So what we said was we would get the students to be guided into the right variable use. So letting d um, equal the number of days the dog was born in, and maybe giving that as a hint. Take more time, allow students to reason, to relate and retrieve what they've learned previously in class, and don't, give them a prohibited time and let them think about it first. That was kind of what we changed in that one. This one, this one we didn't change anything, but we would make this one a homework problem instead of making them do it in class.
So for the closure, um, I didn't really have a closure. I just kind of sent them home with their homework. But this would be a new exit so that we can maybe give them. Um, just how is solving an inequality by using addition or subtraction similar to solving an equation by using addition or subtraction? Because that just kind of brings the whole lesson together, how we're linking with equations and inequalities, and then how is it different, and then represent your answer in some way. So no grade is assigned, it's just kind of something to see if they caught